going to do psychogeometry. Okay, so we're going to do psychogeometry, just the questions. As for the theorems, what I'll do is that I'll be discussing them as we try to answer these questions. It's always better that way, so that we don't take too much time. Okay, so there's this diagram. This is a similar styling to ZIMSEC in Cambridge, how they ask questions on psychogeometry. So O is always the center, almost always, okay? And you have this angle AOC, it's 12. So usually you're given these angles labeled on the diagram, okay? So AOC, you should be able to figure out which angle they're talking about. So you just go to A, just go to O, then AC, the middle angle here. So OA and AC, what they sandwich, that's the angle that they're talking about. So you're given that this is 12 degrees. When you're given that BOC, so BOC, this angle here, you're given that this is 80. Okay, so 80 degrees. And then you're asked to find the rest. Okay, so the way that they ask you normally is the easiest order in which you can discover all these angles. It's not always the case, but it's advised that you start with whatever they're asking you first. Normally, it's what would be the easiest to compute. So, for example, angle OCA. So OCA would be this angle here. And normally, the first questions that they ask you, they are the questions that you can just answer directly. It's either you just have one theorem that you know, or the angle is very obvious. Okay, so normally the first question, for example, part A here, you're just supposed to apply a theorem, or it's very obvious. That's why I told you don't start with any other part, because it might be hard for you, or it might be that maybe part B is dependent on you filling in part A as well. So it's always good to go with the hierarchy in which the angles are given, or in which the angles are asked. Okay, so OAC, OCA. So identify the angle OCA. So it would be this angle here. That's the angle that they want. Okay, so one of the easiest ways to discover angles is whenever you have a triangle leading from the center. Okay, so here we have triangle OAC. It's a triangle leading from the center. Triangle OAB, it's a triangle leading from the center as well. Triangle OBC, it's a triangle leading from the center. These triangles, they're always isosceles triangles, okay? So triangles, this is not a theorem, but then it helps you leading from the center. Are always isosceles. Isosceles, okay. So when we say isosceles, we simply mean, I'm probably butchering the spellings, okay. So when we say isosceles, we simply mean that they are two sides which are equal, and if two sides are equal, it also means that there are two angles which are equal. So for triangle AOC, these base angles here, the base angles, they're always equal, okay. So you can even say triangles leading from the center are always such that the base angles are equal, okay. Are always such that the base angles are equal. And now I'm going to illustrate, and take note of this, okay. It's one of the most common rules that you have to apply. So whenever you have a triangle, as long as this triangle is forming from the center, the base angles must be equal. So for our case, this angle and this angle, they must be equal. So this one will be 12 degrees, okay. So if we were having, let's say, OAB, it means that this angle here, this angle here would be equal to this angle here. The base angles for the triangle that's formed from the center, they're always equal. So here, this one would be isosceles, and then those ones would be 12 like this. Then you're asked to find A or C. So A or C, it means this angle here. This angle is what they require, okay? They need this whole angle here. What do you do? So angles in a triangle, they add up to 180. So looking at the case where this is 12, this is 12, so this is 24. And to get this one now, it should be 180 minus 24. So 180 minus 20, you get 160. Minus 4, you get 156, okay? 156 degrees. So this one will be 156 degrees like this. So 156 degrees. So the idea here, just like I told you, the idea is to recall that the angles of a triangle, they add up to 180. And then you already have these two angles already. They are equal, they are 12 and 12. So 12 and 12, you get 24. 24 from 180, you get 156. That's why this angle is 156. Let's move over. Angle ACB. So ACB would be this angle here. Okay. So how do we find this angle? See, ACB is coming from this chord here. So I'm just making you identify. It's formed from this angle here, from this chord here. So this chord AB is forming this angle here, and it's also forming this angle here. So angle A or C, this angle right here, it's an angle that's subtended at the center. So AB, this chord is subtending this angle A or B at the center. So if it's subtending this angle at the center, this angle must be twice the angle subtended at the circumference. So you have A, B, and C. They're also coming from this. So this angle must be half of this angle here. But then this angle you have to calculate. Remember, 156 is for this part and 80 is for this part. So you actually have to figure out this part as well. So this part would be what? Would be 76, right? Because 76 plus 80, you get 156. Okay. So if this one is 76, this one must be 76 divided by 2. So this one must be 76 degrees divided by 2. So 76 degrees divided by 2, what do you get? Here you get 38. Okay, 2 into 7, you get 3, remainder 1, and then 2 into 16, you get 8. So you get 38 here. So this needs clarification. So let's say you have this angle, this triangle, this circle here, and this is your center. You have a chord here. This chord, let's say it's forming two angles. It's forming one angle at the center, and it's also forming another angle at the circumference. If it's written like this, then it's easy for you to just know, to just see and see that, okay, this angle here must be twice the angle subtended at the circumference. Okay, so one of the ways that they trick you now is they make it such that this one is not going to be subtended at the circumference very far here. They can actually put it here so that you get confused. You see as if it's a different theorem, but then it's the same theorem. You have a chord subtending two angles, one at the center, one at the circumference. Whenever you have such a case, it means that the angle subtended at the center must be twice the angle subtended at the circumference. Okay, so this is how we figured it out. We figured out that this angle A or B, it's formed from AB. Okay, this angle ACB, this angle here, it's formed from the same chord. One is formed at the center, the other one is formed at the circumference. The one formed at the circumference must be half the one formed at the center. Okay, that's how we calculated this 38 degrees here. So we had to discover this angle here because we knew that the whole thing was 156 and a part of this thing was 80. So this one would be the difference, which is 76. So now we have the angle at the subtended at the center. The angle subtended at the circumference must be half. So it's 76 divided by 2, then you get 38. And then you're asked to find angle ABC. Okay, so A, B, and C. So this angle here. So you can say AB, then you identify AB. BC is this angle in the sandwiched by the two chords. That's the angle that we're looking for. So this angle here, what would be the value of it? So here the trick is, don't think that maybe this angle here and this angle here, they're supposed to give you 180. It's always that case when the edge is here, they're touching the circumference. So the best way to discover this angle, you have to discover it in steps. Here you can find this angle here. From the theorem, the basic theorem that I told you, the basic rule that I told you, that every triangle formed from the center, it's always isosceles. So already you have 12 here, you have 38. This one makes 50. So this one must also be 50. Okay, so this one must also be 50 degrees. Now you have this part. You now need this part here. Okay, so you already have this angle, you know it's 76. So you say 180 minus 76 divided by 2. So this one is 76, this angle here. So you need these two angles. So you say 180 degrees minus 76 degrees. Then you get what? You get 104 degrees, right? Then you divide this by 2. What we did was, we know this angle here. We're concentrating on triangle A, or triangle OAB, like this. So we know this angle here, it's 76. And we also know that since the triangle is formed from the center, this must be an isosceles triangle. So obviously, these base angles, this one and this one, must be the same. So here already we know it's 76. So it's 76 from 180, you get 104. Then you divide 104 by 2, you get 59. No, you get 52. Okay. So once you get 52, you now know that this is 52 degrees. So now this angle is equal to 52 plus 50, which is 102 degrees. Okay. So this part here, it was a bit tricky, and see how we had to rely on the other angles that we had calculated. So whenever you're given geometry question, go according to how they ask you. It's almost always the sequence of easiest, working. This is a sequence that's easiest to go through with. Okay, so here you had 12, here you had 38, because this one wasn't really contended. We say that angle at the circumference, angle subtended at the circumference is twice the angle subtended at the center. And angle formed from the same chord, the angle at the center is twice the angle at the circumference. Okay, so and then for this one we had to figure out now in steps and say, okay, let's find this one here. And we use the rule of isosceles triangles. We also use the rule of isosceles triangles for OAB. And then when we find that, we found this out, we just simply added. And then we had 102 degrees. Okay, so what you do is just get a piece of paper, redraw, start from the first part and then redraw, and then try to figure out the angles on your own. There is no one way to do it, but then the ways that I've told you, they're kind of easiest. And then when we're doing these questions, take note of not just the answers, but also the reasons for the answers, because sometimes they may ask you, give a reason. Okay, so you should know angle subtended at the center is twice the angle subtended at the circumference. Angle formed from the same chord, the one subtended at the center is twice the one formed at the circumference. Okay, and also here you can say, you can even give OAB is an isosceles triangle. That's how we figured out 52. Okay, let's quickly move to the next question. Question 2 says, we have a line PQR, it's a tangent to the circle. Okay, so it's a tangent to the circle. The circle as point is, this one is the center O. Okay, QS is the diameter of the circle. Okay, so this one is the diameter of the circle. Whenever you find we have a diameter, conclude one thing: every angle formed from the diameter is always 90 degrees. Okay, so clear out these obvious stuffs, and then here clear out these obvious stuffs as well, because angles formed between the tangent and the diameter or the radius, they're always 90 degrees as well. So now we have 90 degrees, you have 34. So you can actually say 180 minus 34. So 180 minus 34. Why? Because this is just a triangle. P or Q is a triangle. Okay. So here you get 6, here you get 4 here. Then you get 146, right? So 146 now minus 90 degrees. So you get what? So another way to go about doing this, let's move to question 2. Question 2 says the line PQR is a tangent to a circle with center O. Okay, so this is the center. Just like I told you, they always use O here for this. And in this tangent, you're given PQR, it's a tangent. So whenever a tangent meets a diameter or a radius, you always form 90 degrees here. It also means that there is 90 degrees here as well. Okay, but it's the whole angle here. Now notice that I just used this theorem here. It's also 90 degrees. These are obvious angles, and they will help us. Sometimes they do, sometimes they don't. But then most of the times they do help us. Okay. So when you give this and give this, you realize that this one becomes easy now. Already you have 90 degrees here, so these two, they should share the 90 degrees. So it's just simply a case of saying 90 minus 34. So this one will be 4, this one will be 56. So this one will be 56 degrees. Okay. So if you if this complicates things for you, you just say 90 plus 34, then you get 120. Is it 126? So 90 plus 34, you get 120, 124. Okay. Then you say 124 from 180, then you get 56. Okay. So after you get 56 here, vertically opposite angles. This is trigonometry now. So vertically opposite angles here, they are equal. So this one must also be 56 degrees. And once you get 56 here, notice that OST, this triangle here, it's formed from the center. So it must be an isosceles triangle. If it's an isosceles triangle, what does it mean? It means that these angles, this one and this one, they're equal. And if they're equal, what do? You just say 180 minus 56. So you get 4 here, here you get 6, this one you get 2, so 124. Then now 124 is the one that's supposed to be shared by this and this, which are equal. So you just say 124 divided by 2, then you get 62. So this one will be 62 degrees here. And you can actually go directly and say this one, it's equal to this one here. So whenever you have a triangle, so triangle QST here, this triangle here, let me get a faint marker. So this is the triangle that we are talking about here, this triangle. This triangle, notice that it has this thing that I'm going to explain to you. It only applies if the triangle has all its sides at the circumference. And also you have this tangent here. Whenever you have this triangle, this angle here, it's equal to the opposite interior angle. Okay, so you go inside and then opposite, farthest, the further that you go opposite, it would be this one here. So this one would also be 62. So this one would also be, let me rub this. So this one would also be 62 degrees. So this, the size would be 62 degrees like this. Okay, say that you didn't know that this one is 62. How would you go about discovering the correct angle? So you'd say 62 plus 90, then you get 152. Then 152 from 180, then you get this angle here. So let's do it. 152 from 180. So this one would be 8. This one would be 20. Okay, so this one would be 28. Then you write 28 here. Then you say 28 here, this should add to 90, just because you have your right angle here. So 90 minus 28, then you get 62 still. But then notice that what I did is that I took extra steps. You don't need to calculate this. Just remember this theorem, that whenever you have a triangle, this triangle is resting on a tangent. This is the tangent. This angle here must be equal to the opposite interior. It means must be equal to, you go inside and then opposite, like this. Okay, so it would be equal to this part here. And similarly, this angle here must also be equal to the opposite interior. So you go inside, then opposite. So inside, then opposite. Further, as if you see here what this thing is doing. It's covering this side. So it's also telling you that your angle is this side. That's why your angle is this side here. And also, because this one is a bit tricky, take note of it. This one, it's also pointing this side. this side your angle. So it's also saying find your side farthest to the left. So this one would be the side here. Okay. So yeah, so that's one thing. When you can use theorem, or you can go the long way. If you use theorem, then you save time. Writing, it's all about saving time and also writing efficiently. Okay, if you go too, if you wind up, if you go into too many steps, what you end up realizing is that you waste your time, and then maybe it's only 1 mark or 2 marks. So sometimes it's very obvious. Use those theorems; they help you. Let's quickly move to question 3. Question 3 says ABC is a cyclic quadrilateral and PA is a tangent. So this one is a tangent. You see the theorem that I was telling you already, it's applicable. Whenever you see this, already find the triangle which is inside. So you have this triangle A, B, C, this triangle here. Notice how this triangle, all of its sides, they are resting on the circumference, and then it's also resting on the tangent. So that angle formed again, it has to be what? It has to be, you see here, it's pointing this side, this side, this side. So what angle do you find inside? So this one. So this one must also be 20 degrees. Okay, before I even look at anything, I already know. So now we can even fill up these angles here. BAP, so BAP is 20, you're given. This one is 62, you're given. And then already you have this angle here. So you're asked to find ABC. So ABC here. So ABC would be this angle here. That's what you're asked to find. So notice that A, B, C, D, all the sides are resting on the circumference. This is important. If they're resting on the circumference, we call this a cyclic quadrilateral. Okay. Quadrilateral. So for this cyclic quadrilateral, the opposite angles are complementary. Okay, they add up to 180. So here you can even say CBA plus CDA equal to 180 if you're asked to show working. Okay, so CBA would be this angle here plus ADC or CDA, it's equal to 180. Already you know this one. Okay, this one is 62. So 62 degrees is equal to 180 like this plus CBA. So CBA is equal to 180 degrees minus 62 degrees here. So 180 minus 60, you get what? You get 120 minus 2, you get 118. So here you'd be 118 degrees. So ABC equal to 118 degrees. Done. And then now you're asked to find BAC. So BAC, this angle here. So already you have 118 here, and you just need this angle. Already we have 20 here. So 20 plus 118, you get 130, 138. So 138 from 180. So you say 180 minus 138, like this. So you get 2 here, then here you get 4, this, and you get 4, 42. So you get 42 degrees, and that's it. Okay. So what you're supposed to look out for was whenever you see this tangent and then you see these funny angles, look for the triangles that I was telling you about. So for our case, the triangle on which this angle here, it's resting on this chord here. Look for the triangle that rests on the circumference. So it should be this triangle here. Okay, and then we say that this angle, which is inside, it must be equal to the opposite interior angles. Opposite interior angle. And then now we're just using a little bit of trigonometry, and also the theorem that opposite sides of a cyclic quadrilateral, they are equal. Let's quickly move to question 4. So we have the diagram again. O is the center, and you're given this, okay, and you're asked to calculate CBA. So CBA, the one that I was telling you that normally when they test this, what they do is that the first question, it's almost always a theorem or something that you can calculate immediately. So here you have this imaginary chord. You don't see it, it's not there, but then essentially if you have an angle subtended from the same 2 points, which means from the same chord at the center, and then another subtended at the circumference, the angle subtended at the circumference, it's always half. Okay, if this confuses you of saying which one is bigger than the other, obviously the one at the center, because it's wider, it's opening its legs wider, but then this one is kind of stringent because these lines, they have to move a greater distance. So this one would be 100 degrees divided by 2, which is equal to what? 50 degrees. Okay, so this one would be 50 degrees here. So CDA, you're asked to find CDA. CDA here. So what you find out, what you realize is CDAB is a cyclic quadrilateral. Why? Because these sides, all of them, they're on the circumference. This is tricky. Okay, sometimes you can get confused and think COAD, it's a cyclic quadrilateral. It's not. Cyclic quadrilateral, or the angles, or the edges, or the corners, they have to rest on the circumference. So when this one is 50, this one must complement 50. So it's 180 degrees minus 50, which is equal to 130. So this one would be 130 degrees. Okay, so this is how you'd show it. So you want angle CBA like this if you're asked to show working. So CBA, you say, is equal to angle COA divided by 2. Then you proceed now to say 100 degrees divided by 2. Then you proceed to say 50 degrees. Okay, this is how you show working. And for the second one, CDA, you say complementary angles of a cyclic quad. After doing this, now you say you identify the complementary angles. So CBA plus CDA equal to 180 degrees. So you already have CBA. CBA is CBA is what? Is 50. So 50 degrees plus CDA equals to 180 degrees. So you have CDA equal to 180 degrees minus 50 degrees. So you actually get 130 degrees here. So that's how we found out. Okay, so this is how you work it out if they ask you to show working, and also if you just want to show working, but do it as quickly as possible. If it's just 1 mark, then they just want to see the answer there. You're working, you won't get any marks. So it's actually better for you to write. If you want to write anything, just write using a pencil on your paper. Okay, let's quickly move to the last part for today. So we have A, B, and C, which are points on the circumference of circle of center A. Okay, so D is a point on BC. So D here, it's a point on BC such that A or D, it's a straight line. Okay, some of these things you can actually deduce from seeing, and you would need these interpretations where you're not sure. And then PA is a tangent to the circle at A. So PA is a tangent to the circle at A like this. Calculate angles X, Y, and Z. So you have this angle here, 52, and you have to calculate everything else. Okay, so already if you are going by theorem, you would deduce some interesting facts already. So this angle here, it's resting at least in part on this chord. So whatever triangle would be formed for the, which is touching the side. So this one, and this one. Okay, so it would actually be this whole triangle here. And when you're analyzing this whole triangle here, Z must be equal to the opposite interior. So you're looking at the angle which is farthest in that direction, so it would be this one. So this one would actually be Z. Okay, it's just interesting to note. For X, it would be this one here. This one would be equal to X. Okay, so yeah, so let's see. So here I'm seeing this X. This X is touching the this chord here. So now this chord AC. So now I'm looking at this chord AC and thinking to myself, okay, which triangle is formed or from AC, which touches the circumference? So it's obviously A, B, C, like this. It's not any other triangle, it has to be this one. The theorem only applies to a triangle where these edges here, they're at the circumference. Okay, so you have X here, that's what you want to find out. So X, again, it's pointing this direction, this direction, this direction. So your angle should be equal to the opposite interior. So the opposite interior would be 52 here. So already you have X equal to 52. Okay, so X would be 52 degrees like this. So once you get X, you now need you now need Y as well. So here you have 20, and here you have 20, and here you have 52. So let's use this theorem. You have this angle subtended at the center, it's equal to half the angle subtended at the circumference. The angle subtended at the circumference must be twice. So already 52 multiplied by 2, you get 104. So already you now have this angle here. Okay, 104. So 104, it's an angle at the center. So obviously this one should be an isosceles triangle. So this one and this one must be equal. So you're now doing 180 minus 104. Okay, so you get 76? You get 76 degrees. Okay, so 76 degrees you now divide by 2. Why? Because you have these two sides which are equal. So you get what? You get 30, is it 38? So 38 by 2, you get 76, yeah? So this one would be 38, this one would be 38 degrees here. So you have 38, and you have all these angles here. So let's continue again. So these ones, they don't communicate to any angle really. So we have to continue. Which other angle can we find? So here you have 20, 38, you have 52, 38. You can also find this angle here. It'd be simple. Okay, so you can say 20 plus 38, then you get 58, or you can say 76 here, 76 plus 20, then you get 96, 96 plus 52. So 96 plus 52, you get 8 here, then you get 140, 148. So 148 from 180, because you want to find this angle here. So 180 minus 148 would be equal to 2 here, this one would be 5, and then this one would be 32. So already you have 32 degrees here. Once you have 32 degrees, by the way, we already know the value of z now, because we said z is equal to this angle here, opposite interior. It's we have this tangent, and we said this triangle is the triangle that's concerned, the triangle that has all its legs at the circumference. So this angle must be equal to the opposite interior angle. So 38 plus 20, you should actually get 58 here. Okay, so x is equal to this, y is equal to, we have to find y, and z is equal to 58. So y is this one right here, of which this one, it's resting on a straight line, right? So 180 minus 104, then obviously you get 76. So this one must be 76. Okay, so this one was a bit tricky, and we just did everything more or less haphazard fashion, but then we were applying the proper theorems, or the proper rules. And the most important rule was the rule of the tangent and the so let me actually, so you have this and you have a tangent. Okay, so I'm very lousy at this. Very lousy at drawing stuff. So yeah, so you have this. If you have a triangle now, being formed, and then this triangle is formed from the tangent, but then it's also touching the what? The circumference. Okay, so like this, the rule is that this angle here, theta, see how this one it's pointing this side, this side, this side. It also means that's where you have to find that angle. So the angle is find opposite interior, so it should be this one. These angles, they should be equal. And similarly, this angle here must be equal to the opposite interior angle, which is this one. And those were the two hardest theorems that we applied here. And we also applied the theorem that the angle subtended for or at the center is twice the angle subtended at the circumference. So we had 52 already, and then we just realized that this one must be twice that. So it's 104. So yeah, that's it. Thanks for watching. We'll actually do a part 2 of psychogeometry and perhaps a part 3 as well. Just getting new questions and then just answering them. Now you have to go back and actually try to recreate the question and then try to understand it on your own as you write, and then you compare the answers there. Okay, because if you just think that okay, now I now know what to do, what you realize is that there's something called the Dunning-Kruger effect, where you think you know, but then you actually realize that knowing and actually practicing, they're two different things. Sometimes you have to practice first before you have adequate knowledge, the knowledge that would make you pass in your exam. Okay, so I wish you well, and if you have any questions obviously on psychogeometry or any other topics that you want me to touch on, this was requested by a few people, so on psychogeometry, and then I just thought let me cover it. So if there is any area that you want us to cover, also just put it in the comment section below. Thanks so much for watching. Make sure you share, like, and subscribe. Yubo out.